two different color. So let's say we are using a green color and another color we are using is a purple color. Total how many pieces of triangles are there? 10 pieces are there, including this green one and this purple one. Each piece measurement is given as 20 centimeter, 50 centimeter and 50 centimeter. How much cloth of each color is required? So if 10 triangles are there, what I am going to assume that 5 triangles are from green color and 5 triangles are from purple color. Just a moment. Yeah. So 5 triangle each are having. Okay. And let me write what exactly it's asking. It's asking that how much cloth of each color is required. For the umbrella. So each color means what? Either we are going to focus on the purple one or we are going to focus on the green one. All are having same measurement. So at first we will be finding the area of one triangle. How many total triangles are there? 10 triangles. So at first we will be finding the area of one triangle. Now total how many triangles are there? 10 triangles. So do we need to find the area of all the 10 triangles? No. We have to find the cloth of each color. That means we have to find the area of 5 triangles. Okay. So first we will be finding the area of one of the triangle whose sides are A is 50, B is 50, C is 20. We will be using Heron's formula. That is S is equals to A plus B plus C over 2. That is 50 of plus 50 plus 20 divided by 2, that is 120 by 20 to 6 we got from here. Now is it 6? 120 by 2 was there, by mistake I have written 20. It will be 2. So here we'll be having 60. Okay, now area formula we already know, that is under root S minus A, S minus B, S minus C. That is under root S is 60, 60 minus 50, again 60 minus 50, and then 60 minus 20. Now we just have to solve it to find area of one triangle. After that, total 10 triangles are there, but 2 different colors has been used over here. So 5 triangle from each color we are considering. Now the question is asking about how much cloth of each color is required. How much cloth is required to make the total umbrella? That is not asking in the question. How much cloth of each color? So if 5 triangle each color is having, then we just have to find the area of 5 triangle. Okay. So here we'll be getting area. Let's see. 60 times 10 times 10 times 40. 10, 10, let's take it out. 60 means 6 into 10. 40 means 4 into 10. So again we got a pair of 10. Let's take it out. Now we are having 6 and 4. So 2 into 3, 6 and 2 into 2, 4. So we ended up getting 100 root. This 2 will come out root 6. 200 root 6 This much centimeter square is area of one triangle. Area of one triangle. We have to find here area of 5 triangles. Therefore, area of each colored, what was there? Area of the cloth required for, cloth of each color is required for umbrella. So, cloth required for each color in triangle, in an umbrella, that will be 5 times 200 root 6. Here, this question is very simple. We just have to find the area, but only one trick is there, that we have to understand that if total umbrella is made up by using 10 triangles, then 5 has to be 5, like 2 colors has been used. So one of the color is having 5 triangle, another color is having 5 triangle. Now area of the cloth used to make each color portion. So that we have to find. Once we'll be finding area of one of the triangle into 5. Is it clear to everyone?
Yes, ma'am.
Let's move to the next one. Number 7. So number 7 says a kite is in shape of a square of diagonal 32 centimeter. We are having a kite. Okay. This type of kite we are having, the shape of the kite is a square. So we know a square is having a property. This is a, this is a, this is a, and this is a. All the 4 sides are of same length with diagonal 32. Yeah, anyone saying anything? Diagonal is of this kite is given as 32 centimeter and an isosceles triangle of base. So here we are having an isosceles triangle. This one is an isosceles triangle. Okay. Of base 8 centimeter and sides 6 centimeter. Each is to be made of 3 different shade and an isosceles triangle of base this and side this is to be made of 3 different shade as shown in the figure. How much paper of each shade has been used in it? So this is one of the shade. This is another shade. And the third one. This is first, this is second, and the green one is third. We have to find the area of each and every one, and then we will be just giving how much paper is used. So whatever area is there, that much paper has been used to make this kite. Okay, so basically we have to find the area of the upper one and the area of this downward triangle. So on the top, we can see 2 triangles or we can see a square. We can directly go and find the area of the square. But do we know what is the side of the square? We don't know. Okay. Diagonal, we know it's 32 centimeter. So with the help of diagonal, we'll be finding the side of this square. Okay. So how we'll be finding the side of the square? We know diagonal means what? If we are having a square like this, where side is A, and A. And if we will be drawing diagonal like this, we can see here we are having a right angle triangle. There is a formula for diagonal also, but let me show you from where the formula came. So here we can see a right angle triangle where two sides are A and A, and obviously it's a square, so here 90 degrees is there. Okay, so by Pythagoras theorem, diagonal came out. What the Pythagoras theorem says, that A square plus A square will be equals to diagonal square. Yes or no? If you will look at this teeny tiny square, are you understanding that A square plus A square is equals to hypotenuse square? That is the diagonal only. Yes or no? Are you understanding?
Yes, ma'am.
So here 2A square we are having, that is diagonal square. Diagonal is root 2 and A. This is the formula for diagonal of the square. Root 2A, root 2 into side. Directly, I can say the formula. That formula for diagonal is root 2A. But you must be thinking from where this root 2A came, from where this root 2 into side came out. So this is how we have got root 2 into side. That is the formula for diagonal, or that is the relation between diagonal and the side of the square. So let's use this relation that we know that diagonal is equals to root 2 into side. If side is not known, that is A, and diagonal is known, that is 32. Let's do the calculation. A will be 32 by root 2. Have you done the concept of rationalization, that whenever this root is there inside in the denominator, we'll be multiplying with the same number, and that's how we will get rid of this root. Root 2 into root 2 will be only 2. Do you know it? This concept was there in chapter 1, I believe, right? Let's cancel them out. 2 1 times 2, 2 6. So 16 root 2 is the side of the square. Now, if we know the side of the square, why to go for that part, this part area? Directly we can find the area of the square. Okay, let me read the question again. Is it asking about the total area or what? So here it says a kite in so yeah, it says that how much paper of each shade has been used in it. Okay, so I here it's written in the question that how much paper of each shade has been used. So one by one we have to find the area. First the upper triangle, then the downward triangle, then the green one. Okay, so let's do it. If we will be focusing on the upper triangle, this one, we will be focusing on this triangle. Here we know the side we have already got 16 root 2. This is also 16 root 2, and diagonal we know that is 32. So easily by Heron's formula we will be able to find the area of this triangle. Let me check whether we can find the area by using the above the older formula 1 by 2 into base into height. Just a moment. So base is 32, and since it's a square, so both the diagonal will be of same length. Okay, whenever we are having a square or a rectangle, both the diagonal are of same length. If this is 32, and that will also be 32, and we know in a square diagonal bisect each other. So here if we will be taking only this much part, Or if we will be taking only this much part, this much, then I can say this much is half of 32. Okay, so this will be half of 32, that is 16. So yes, easily without Heron's formula, we will be able to get the area of this triangle, because we know base is 32 and we know height is 16. Are you getting it?
Yes, ma'am.
Everyone? Why
Yes,
we are
ma'am.
not going for Heron's formula when we know all the side? Can you see it? It looks like 16 root 2, 16 root 2, and later on calculation can be very difficult. Can you see it?
Yes, ma'am.
That's why we are trying to avoid it. If no other way will be there, obviously we will be going by that way. Okay, so I'm not taking this way. From the very beginning only, we are not going to do anything. We are not going to find the side or something. With the help of diagonal only, we can find the area of the triangle. So this total thing, whatever we have understood, that is okay for the concept. But this question, freshly I am drawing a kite. Kite is like this. We have to find the area of this first, this second, and this third. What we know that diagonal is of 32 centimeter. So with the help of diagonal, easily we can say this one is also a part, half of the part of the diagonal, which is also 90 degree. It is at 90 degree over here. So it's working as a height also, and it's half of the part of the diagonal also. So it is 16 over here. Now 1 by 2 into base into height. That formula we will be applying, that is 1 by 2. Base is 32 and height is 16. Easily we will be getting the area of the above triangle. 2, 8 times 16. Please do the calculation and tell me what exactly are we getting from here. What are we getting? 32 into 8 is 8 2 times 16, 6, carry 1, 8 3 times 24, 256. That is the area of the above triangle. Okay, area of this first part, first shaded part, this much centimeter square. What is the area of the second part? Both are exactly same, since both are the part of a single square. So we can say this area will also be 256 centimeter square only. One by one we have to find the area. Okay, we don't have to find the total area. Okay, now the bottom one area also we have to find, the third portion. What we know about the third portion, that the base is 8 and it's an isosceles triangle. So base is 8 and it's an isosceles. Here we can apply the concept of Heron's formula to find the area. That's it. It's very simple, right? This much only calculation is there. Can you see it?
Yes,
Here
ma'am.
we will be finding area by using Heron's formula, because all the three sides are known. Is it clear to everyone? Is it clear?
Yes, ma'am.
Okay, let's move to the next one. So no need to find the side. Without side only, we are able to calculate the area. Because once we got the side, we found that side is in root or something. So rather than going for side, just do it like this. Okay. Now the next one, the next question is, A floral design on a floor is made up of 16 tiles, which are triangular. The side of a triangle, floral design is made on the floor, just in the shape of triangle. Okay, this type of designs are there. You must be thinking it is not a triangle, but yes, meanwhile, there is a section in between, and this is a triangle, this is a triangle. And even though it doesn't look like same over here, in book it is given as a same triangle, all are same. How many total triangles are there? 16 triangles are there. Side of the triangle is given as 9, 28, 35. Okay, it's asking about find the cost of polishing the tiles at a rate of 50 paise per centimeter square. So we are having 16 triangles, like a tiles is there which is having 16 triangles, and we have to find the cost of polishing the tile at the rate of 50 paise per centimeter square. If you will look at this unit is indicating that we have to find the area at first, area of one triangle. So easily we will be able to find the area of one triangle by again Heron's formula, because all the three sides we are already having in hand. So a plus c, a plus b plus c by 2, that will be 9 plus 28 plus 35 over 2. Let me check what exactly we'll be getting from here. So we will be getting 72 over 2, that is 36 centimeter. Now Heron's formula, let's apply it. That area of the triangle will be, area of one triangle will be under root s, that is 36, s minus a s minus b s minus c. And from here we'll be getting the area. Now we have to calculate the area of the complete, the total tiles, because we are going to polish the complete tiles. So area of one triangle, whatever we are getting, 16 triangle area will be, whatever we have got from here, that multiplied with 16, that will give us the area of all the 16 triangle, or the area of complete tiles. Now, do we need to find the area over here? No, we have to find the total cost of polishing. So 50 paise is the price for 1 meter square. This is the total meter square, centimeter or meter, centimeter square we have found as a area of complete tiles. Now 1 meter square, 1 centimeter square cost is 50 paise. So we have to find for this much centimeter square, I mean for this much centimeter square, what will be the price? Will you be able to do it? That is 50 into whatever we have got over here. Are you getting it?
Yes, ma'am.
So I'm leaving this for you. Okay, let's do the last one. A field is in shape of trapezium. We are having a field which is in shape of trapezium. Let's say I'm drawing a trapezium like this, okay? Whose parallel sides are 10 meter and 25 meter. The non-parallel sides are 14 meter and 13 meter. So this is 14 meter and I am keeping this as a 13 meter. Find the area of the field. We have to find the area of the field. Now what is the formula for area of the trapezium? Anyone? 1/2 times?
Into height,
Only height?
breadth.
Sum of parallel sides into height? Yes or no?
Yes, ma'am.
Let's write it. So 1/2 times sum of parallel sides times height. We already know the parallel sides are, if we are having a trapezium ABCD, we already know AB is parallel to CD. So sum of parallel side, it's very simple to do, add 10 and 25. But what about height? Do we know height over here? No, we don't know height over here. So how we'll be finding the height? We have to find it. So how we can find the height? So what we can do over here, we can just draw a line parallel to AD like this. I'm going to draw a line parallel to AD. AD parallel to, let's say, BE. How? By construction. So we have done a construction by ourselves in such a way that BE is parallel to AD. Why we have done the this type of construction? So that here we can see one parallelogram, this one, and one triangle. Maybe this parallelogram will help us, or maybe that triangle will help us. So let's see which one is going to help us. So here we can say that ABDE is parallelogram. Why? Just because of our construction. Because we already knew, it was known to us that AB is parallel to CD. And if you will cut the CD, then also both the line will be parallel. If two lines are parallel, and if you are going and cutting one of the line, then a smaller part of that line will still be parallel to the other line. Okay, so AB was parallel to CD, and from here only it came out that AB must be parallel to DE, because DE is just a smaller part of CD, right? Getting it? And we have done the construction in such a way that AD is parallel to BE. So if opposite sides are parallel, it has to be a parallelogram. So this is a parallelogram. Therefore, we can say that opposite side will be equal also. That is, AB will be equals to DE and AD will be equals to BE. So if this is 10 centimeter, if this is 10 centimeter, I want to say this much will be 10 centimeter only, because it's a parallelogram where opposite sides are parallel and it will be equal. If this is 13 centimeter, I want to say that this one will also be 13 meter. The total. Are you getting it? I'm talking about the total.
Yes.
Okay. Now, if we are talking about the triangle, I mean the triangle BEC. Do we know all the side? One is 13, another is 14, and this one is, can I say this one is 25 minus 10? Can I? The total was 25. If this much is 10, the rest of remaining will be 25 minus 10, that is 15 meter. Yes or no?
Yes, ma'am.
So this much is 15 meter. Okay. Easily we will be able to find the area of this triangle. Let's find the area of triangle BEC. Okay, let's do it. Area of triangle BEC, where one of the side is 13, another is 14, another is 15. 13 meter, 14 meter, and 15 meter. Let's do it. S is equals to A plus B plus C by 2. That is 13 plus 14 plus 15. Since height is not there, this much of struggle we have to do. Okay. Since the height of the trapezium is not given over there. That's why one more Heron's formula came into existence, just because of the struggle of this height. Every time we were not having the height of the triangle, and then so the mathematician came and given one magical formula which can do the work without height also. You can see, just because height is not given over here, we are doing a lot of different constructions and everything. So let's find area of that triangle. That is this by 2. 5, 4, 9, 10, 11, 12, 2, carry 1, 1, 2, 3, 4, 42 over 2. Is it? Please keep on checking the calculation. Okay. Are you doing it with me? 2 times 4, 1 times 2. This much. Everything is in meter. This much meter we will be having. Now area will be under root S minus A, S minus B, S minus C. Let's do it. Root 21, 13, 7, 8 into 14, 6, 7, 21, 15, 5, 1, 6. So here we'll be having, let's break this 21, 7 into 3. Let's break this 8. It will be 2, 2, 2. 7 is as it is, 2 into 3. Let's check the pairs. So here I can see this 2 is in pair and this 2 is with this 2. So we got 2 pair of 2. We got 3 also in pair. We got 7 also in pair. Let's write all of them very carefully. So 7 is in pair, 1 3 is in pair, 1 2 is in pair, and then another 2 is also in pair. Okay. 21 into 4, 84 meter square is the area of that triangle. That is the name of the triangle is BEC. Okay. But what we want to do? We want to find the height of this trapezium. Then and only then we can find the area of the trapezium. Now, if you are thinking, let's find the area of the parallelogram and let's add triangle area and parallelogram area. So what is the rule for area of the parallelogram? Base into height. Again, the discussion about height. Do we know height of this parallelogram? No, we don't know. This parallelograms height, we don't know. Height means what? If we will drop a perpendicular like this, altitude like this. Just a second. Yeah. So even though we are thinking about finding the area of the parallelogram over here, that is also not possible because of the height only. So once we got the area of the triangle, now that triangle area we will be using to find the height of this trapezium. Okay. So we have found that we are having one triangle on the side and that triangle area is 84 centimeter square. So let's write it. Area of triangle is 84 centimeters square. Now we know one more formula for finding the area of the triangle, that is 1 by 2 into base into height. So here I am going to write the older formula, 1 by 2 into base into height, because on day 1 only I have shown you whatever method you are using to find the area, everything will give you the same answer. Older method, new method. If you are talking about one triangle, both the method are like will, by using both the method you will land at the same place. Okay, so that's why here older formula I am writing, that is equals to area of the triangle, the value that is 84 centimeter square. Why I am doing so? So that from here we can get the height of this triangle. Once we will be getting the height of this triangle, that is this much, this height, then we can say the height of our, then we can say that the height of our trapezium is the same height. Whatever triangle is having the height, that height is the height of the trapezium also. And now we can get back and can find the area of the trapezium. So let's do it. Let's find the height of the triangle from here. What was the base of the triangle? The base was 15. On 15 centimeter, on 15 centimeter base, we are dropping the height. And we can find the height by using the known area of this triangle. Height is equals to 84 times 2 by 15. Let's see whether we can cancel them out. So 3 5 times 15, 3, 2 times 6, 3 8 times 24. So we are having 28 into 2, 56 by 5. So this is the height of the triangle. You can convert it in decimal, you can keep it as it is. This is the height of the triangle, which is also the height of the trapezium. So this much centimeter. I will be summarizing the whole thing if it is not getting clear to you. Just understand this much for now. We will be getting back to the whole thing. Now area of the trapezium is equals to 1 by 2 times sum of the parallel sides. What was the parallel side? It was 10 and 25. Okay. 1 by 2, 10 plus 25, sum of parallel side into height, 56 by 5. 1 by 2, 10 plus 25 will be 35 times 56 by 5. 5, 7 times 35, 2, 2 times 4, 2, 8 times 16. 8, 7 times 56, 6 carry 5, 7, 2 times 14, 15, 16, 17, 18, 19. We got this much centimeter square as the area of the trapezium. Now let's get back to the whole scenario. What exactly we did. So we were having a trapezium where all the 4 sides was given in the question itself. So basically we were having a trapezium like this, where this side, this side, this side, and this side was given. And it was just asking us to find the area of this trapezium. Now the area of the trapezium is 1 by 2 into sum of parallel side into height. We know parallel sides are this one and this one, but we were not aware of the height. So what we did, height is what? In this trapezium, if we will focus carefully, then we can see this is the height of the trapezium. If we will be dropping a perpendicular like this, 90 degree, that is the height of this trapezium. So in trapezium A, B, C, D, if this is F, BF is the height. So it's 1 by 2 into sum of parallel side means AB plus CD is the parallel side into BF. That's what we needed to have. ABCD is known 1025, but BF is not known. So for that, what we did, we have done one construction. How we have done the construction? So we have drawn one parallelogram. We have drawn something like this. Okay, something like this we have drawn. And we said it, this is E. Now ABED is a parallelogram. Why? Because we have drawn this parallel to this. And already AB and DF, CD, D, it's parallel with each other. So we said that it's a parallelogram and the other one is a triangle. Okay. Since it's a parallelogram, if this is 10, this much will be 10. If this is 13, this much will be 13. Now, if we are focusing on the triangle, we can see all the three sides of the triangle are known. This will be 25 minus 10, that means 15. So all the three sides of this triangle BEC is known and we can find the area of the triangle. But our purpose is to find the area of the triangle? No, our purpose is to find this BF. BF. How we will be finding BF? So first we will be finding the area of this triangle and then that area value we will be using to find the height of this triangle. Getting it? Are you getting it?
Yes, ma'am.
Yes, ma'am.
So first we found the area of this triangle that came out as a 84 centimeter square by Heron's formula. Okay. And then that area, this triangle's area, we have used for finding the height of the triangle. So we have said that this area must be equals to 1 by 2 into base, that is 15, into height not known is equals to 84 centimeter square. Here we got the area BF. This height, area not, this height BF we got from here, that is 56 by 5. And that BF, now we have gone to the original thing, that is area of the trapezium, and we have substituted the value, each and every value. And that's how we got the area of the trapezium. So is it clear to everyone? Is it clear?
Yes, ma'am.
So this is